Alright, good morning and welcome to Master Talker online class. Today we'll be talking about complex numbers in topic, okay? Let me tell you what happened in 1902. I was there. We were having a conference and somebody brought this mass. He said x squared minus 1 is equal to 0, and we solved it. We got x squared is equal to 1, okay? X becomes what? The square root of 1 plus or minus. So therefore x is now what? Plus or minus 1. So I now raise up my hand and say, okay, let's change the sign and know what the answer will be. Okay, we now say x squared plus 1 is equal to 0, which means x squared is equal to minus 1. So x is equal to what? Plus or minus the square root of minus 1. So x is equal to what? Plus or minus. We couldn't find, we started thinking of the square root of negative number. We were thinking about it, we couldn't find it in the real world. We now say let's take it to the imaginary world. We now say let's imagine it to be anything. So and the first letter of imagination is I. So that is how we got that what? That the square root of minus 1 is what? I. Okay? So this implies that anywhere you see the square root of minus, you put I. The square root of minus 4 is what? The square root of 4 normally is 2. But the square root of the minus will make it what? 2i. Okay? The square root of minus 2. We don't know this. It's not a perfect square anyway, so it should be what? Root 2. But the square root of minus is what? I. Okay? So that is that. Now let's go to simplification of a complex number. To simplify complex number, we know that what? That the square root of minus 1 is taken as what? I. So if we decide to square both sides, minus 1 all squared is taken as what? I squared. Square will cancel square root, which means I squared is equal to what? Minus 1. Okay? So you need to know that what? I squared is equal to minus 1. Now what about I raised to power 3? I raised to power 3. Now what do? You must start from these two. Okay? The one we know normally is what? I squared. So we can say that I raised to power 3 is simply saying I raised to power 2 plus 1. Like this. Okay? I raised to power 2 plus 1. And in this is said that this is equal to what? I raised to power 2 times I raised to power 1. Okay? And we know that I raised to power 2 is what? Minus 1 times I, which will give you what? Minus I. Are you getting that? So the next one is I raised to power 4. Let's know what I raised to power 4 will give us. I raised to power 4 is simply saying I raised to power 2 normally. 2 times what? 2 times 2. Okay? In fact, this one is 2 times 1. How did I get this? In fact, it should be like this, please. 2 times 1, then plus 1. Okay? How do you get it? Just divide anything you see here by 2. 4 divided by 2 give you what? 2. So 4 is something saying 2 times 2. Okay? So that's how I got this. So this is equal to what? I raised to power 2. Then all raised to power 2. You can write it I squared like this. Then all raised to power 2. 2 times 2 will still give you 4. So and I raised to power 2 is what? Minus 1 all squared, which will give you what? 1. Okay? So look at I raised to power 5. Let's do I raised to power 5. I raised to power 5. Let's do the same thing. 5 divided by 2 will give you what? 2 remainder 1. Is it not? 2 remainder 1. So 5 is the same as saying 2 times that 2. Remainder means plus 1. Okay? So 5 is the same as saying I raised to power 2 times 2 plus 1, which will give you what? I raised to power 2 or I raised to power 2 bracket 2 share the plus times I raised to power 1. Are you getting that? According to indices. Okay? So what do we have now? We now have that this is equal to I raised to power 2 all squared dot I. And I raised to power 2 is what? Minus 1 all squared dot I, which is what? Minus 1 squared will give you what? 1. 1 times I will give you I. Okay? So, can I clean here? Yes. So look at this now. Look at, for example, I raised to power 273. For example, this is equal to, just say 273 divided by 2. So what do you have? 2 divided by 2, 1. 2 divided by 7 is 3 remainder 1. Put it here. 13. 2 divided by 13, you have 6 remainder 1. So which means 273 means 2 times this. 2 bracket 136. Remainder is plus 1. So what do? this is I raised to power 2 bracket 136. Then what do you do? Plus 1. So you have to separate it. Remember that the plus is at the power. So let's separate it. It means I raised to power 2. Okay. Sorry, it's not like this. Sorry, it should be like this. I raised power 2 times this, then plus this. So let us separate it. It's now I raised power 136 dot I raised power 1. Okay, because of the plus. So what do we have now? We now have separating now I raised power 2 all raised power 136 dot I. So what do we have now? I raised power 2 will give you minus 1 all raised power 136 dot I. Now don't forget that if the power is even number, the minus will disappear. But if the power is an odd number, the minus will remain. So if it will disappear, I'm having minus 1 times I, which is what? Minus I. So this is how to solve this. But this has a shortcut. It has a shortcut. Can I clean here? Okay, let me show you the shortcut now. Let me show you the shortcut. The shortcut says, first of all, write that I squared is minus 1 that we know. Okay? Now this will show you that you are having 1 here. So an I is even number. It says if the power is even. If the power is even, we expect 2 answers, which is either 1 or minus 1. Okay? But if the power is an odd number, if the power is odd, what are you expecting? You expect I or minus I, as simple as the I or minus I. Okay, so that's all. In any question you have like this, you have to check if the power is an even number. You're expecting either 1 or minus 1. But if the power is an odd number, you are expecting what? That is, if you have I raised to power n, if this n is an odd number, you expect what? I or minus I. Then the problem is, when do you choose the negative 1 and when do you choose the positive 1? We choose the negative 1 by dividing the power again by 2. If you half of the power, if you divide the power by 2, the whole number part, if it is even, you go for the positive. If it is odd, you go for the negative. Let's do it now. I have I raised to power 2. Now this is even number. So since it's even number, I'm expecting what? 1 or minus 1. Okay? Now the next thing I will now do is what? 2 divided by 2. Divided by 2. I'm having 1. And this 1 is an odd number. So I will take the negative 1, which is minus 1. Look at this one now. I raised to power 3. Let's go. 3 is an odd number. I'm expecting I or minus I. I will now say 3 divided by 2, which is what? 1.5. We don't need the point part. We only need the whole number part, which is 1. 1 is equally an odd number. So I will take the negative 1, which is what? Minus I. Okay, the next one now. I raised to power 4. Let's do it again. 4 is even. So I'm expecting what? 1 or minus 1. I will now say 4 divided by 2. What do you have? You have 2. Okay, and 2 is an even number. So I will take the positive 1. I'm having 1. The next one is what? I raised to power 5, which is what? 5 is an odd number. So I'm expecting I or minus I. I will now say 5 divided by 2, which is what? 2.5. I don't need the point part. This 2 is an even number. So I'm taking the positive 1, which is what? I. Okay, let's do it again. I raised to power 276, for example. So let's do that again. 276 is an even number. So I'm expecting what? Either 1 or minus 1. I will now say 276 divided by 2. What do you have? 138. And 138 is an even number. So my answer is what? 1. So get this for me. I raised to power 2375. I raised to power 1000. Okay, do these two for me and drop the answer at the comment section. Okay, so the next thing we'll move into is addition and subtraction of complex number. Addition and subtraction of complex number. How do we add or subtract complex number? Now, so complex number is as good as someone that is solving SOLD, okay? You know, in solving SOLD, we only add or subtract the coefficient. The real part add the real part, the SOLD part add the SOLD part, okay? So the same thing here. If you have a complex number, look at how we write a complex number. In fact, from the definition of a complex number, sorry, that is where I'm supposed to start with. How do you define a complex number? A complex number C is defined as a set of A plus BI, such that A and B are elements of real numbers, okay? But B must not be equal to 0 and I is equal to the square root of -1. This is the definition. You can go to my video on number system. You will see this definition there where I explained it very well, okay? So if you have a complex number like this, A plus BI, and you want to add it with another complex number, D plus, or let me say C plus DI, okay? Now, what happens is that the real part will add the real part, and the imaginary part will add the imaginary part, okay? We call this one the real part, and this side the imaginary part. So what do I have? This thing will be equal to what? A will add C, while plus BI will add what? DI. But they have I in common. So it will be what? A plus C. Then plus, you add only their coefficient. B plus D, putting the I they have in common. So let me give you, the same thing is applicable when you have minus. So the same thing is applicable when you have minus. So let us do that now. Let us do that. Example. If I have 3 minus I, okay, plus minus 2 plus 3i, okay? So let us go. What do we do? 3 and minus 2 will go together. So 3 plus minus 2 will give you what? Minus plus is minus. So I'm having 3 minus 2, which is 1. I'm having 1 plus, okay, minus 1, only the coefficient is what you're adding. Minus 1 plus 3 will give you what? Plus 2. Then put the I they have. So the plus is plus. I'm having I plus 2i. Or in fact, you may not even put this plus. Anything you get. Let me give you another example. If you have minus 3 minus 4i, okay, plus, or let me even use minus 6 plus 2i. Okay, let's do that. Now, in fact, you can decide to open the bracket with the minus, because minus is a very powerful something. So let us open the bracket with minus. So I'm going to have minus 3 minus 4i, this time this, minus 6, this time this, minus 2i. So let us now do it direct. Now, minus 3 minus 6 will give you what? Minus 9, standing here. Minus 4 minus 2 will give you what? Minus 6. Then put the I. You see, it's very simple. That is how to add or subtract complex number. In fact, for this one, let me clear with the plus so that everything will stand the way it is. So I'm having 3 minus I, okay? Plus minus is minus, minus 2, plus plus is plus, plus 3i. So let me now add 3 minus 2 will give you 1. Minus I plus 3i, minus 1 plus 3 will give you plus 2. Then put the I they have. So that is how to add or subtract a complex number. Now let's go to the multiplication and division of complex number. Okay. Multiplication and division of complex number. So how do we multiply or divide complex number? It's as good as multiplying or dividing a SOLD. SOLD will help you very well to understand this, because we are going to do rationalization of complex number. And I taught you rationalization of SOLD. So you can go to my video on SOLD, okay, to learn that. So now I have, if you have A plus BI and you want to multiply with C plus DI, okay? So now what do? The same thing with SOLD. Use this A and multiply everything. Use this BI and multiply everything. And anywhere you see I multiplying I, the answer is what? I squared. Don't forget, which is what? Minus 1. So anywhere I multiply itself, the answer should give you -1. So let us go. A times C, you have AC. A times DI, you have what? ADI. BI times C, you have what? BCI. Okay. BI times DI. First of all, B times D. B times D will give you BD. Then I times I, you open bracket and put -1. So my answer becomes AC plus ADI plus BCI minus what? BD. Okay, because minus times this will give you minus. So let's bring the real part together. These are the real part, which is what? AC minus BD. They are the real part. Then the imaginary part is now, they have I in common. So I'm having AD plus BC having the I in common. So that is how to multiply a complex number. Let me give you an example so you understand what I'm saying. For example, if I have 2 minus 3i, okay, it's being multiplied by maybe 4 plus I, or let me say plus 2i. 3 plus 2i. Okay. Okay, I don't want to use the same thing. Okay, so let's go. Let's do that. Now, don't forget that if you have 4i times 3i, is as simple as saying 4 times 3, 12. I times I, -1. So my answer is now what? -12 without any I. Okay, so that is that. Don't forget this one before I leave the small one and move to complex one. So let's go. 2, we multiply everything first. 2 times 5, 10. 2 times this, 2i. Sorry, 2 times 2, 4i. Okay, I'm done with 2. I'm now moving with -3i. -3i times 5 will give you -15i. Minus times plus, minus first. 2 times 3 times 2, 6. I times I will give you -1. I told that anywhere I times I is -1. So my answer is now what? 10. These two will give you 4 minus this will give you -11i. Then minus is what? Plus 6. So this plus this will give you what? 16 minus 11i. You see, as simple as that. That is how to multiply complex number. Okay. So the next thing we are going to do is the conjugate of a complex number. The conjugate. If you remember conjugate of a sword, that is when it will help you to remember conjugate of a complex number. Before we get to division, let's do that. Okay. Before the conjugate, let us do rationalization. Okay, now we don't leave sword at the denominator. Okay, the way we don't leave we don't leave complex number at the denominator. The way we don't leave sword at the denominator. You cannot have 2 divided by 3i. Is not possible. You have to rationalize it. Whenever you get I at the denominator, you rationalize. How do you rationalize? Remember your sword. It will be 2 over what? 3i times the same what? I over I. Some will say times 3i over 3i, the same thing, because 3 will cancel 3. So just pick only the I. So it will now give you this is equal to 2 times this, 2i. 2i times 2i. In fact, 3 times invisible 1 here is 3. And I times I will give you what? -1. So my answer is what? 2i over what? -3. So my answer is now -2 over 3i. Okay, you see the way I'm writing it? You write the constant outside, then write your I. We don't leave plus up. Plus minus is minus. That is why we write it this way. Okay, so that is how to rationalize. Can I clean? Okay, the next one, let me give another example. -2 over just I. Okay, instead of saying -2 over I times I over I. What do you have? -2 times I. -2i. I times I is what? -1. Minus cancel minus. So I'm left 2i over 1, which is what? 2i. Okay? So that is rationalization of a complex number. Okay, that is for division. Now what if I have this? What if I have a plus bi divided by maybe a or c minus di? Now the complex number is no longer single, it's being added or subtracted by something. So we are going to use the conjugate to rationalize. And don't forget what conjugate is. If I have a plus bi, the conjugate of a plus bi is simply a minus bi. Okay, if I have c minus di, the conjugate is what? C plus di. Okay, if I have minus a minus bi, the conjugate is what? My interest is for the I, so the conjugate is what? Minus a plus what? bi. Okay, so that is that. Something that will make it to look like a difference of two squares. Okay, and in difference of two squares said the first person minus the second person, and that same first person plus the second person. So once they can form a difference of two squares, you have gotten the conjugate. Look at it, the first person plus the second person and the first person minus the second person. So this is the conjugate. Look at the first person minus the second person and the same first person plus the second person. Okay, so once if the multiplication of two of them is difference of two squared, then you are good to go. So how do you rationalize this? You rationalize this with the conjugate. So you are going to say times c plus di over c plus di. So let us multiply. Let's put them in bracket. Remember that this first person will multiply everything and the second person will multiply everything. Like I told you in sort, the denominator will always form difference of two squares because we are rationalizing with the conjugate. So I know what the denominator will form. The denominator will always form the first person I'm having, which is c squared, minus the second person, which is di squared. This is what it must form. It's a must. Because it means the first person minus the second person, which is this one, and that's the first person plus the second person, which is this one. So this is what it will form, which is difference of two things that are squared, difference of two squares. So that is what the denominator will always form. Then the numerator we can multiply out. Or if you cannot remember that the denominator will form difference of two squares, just do it like this. Just do it like this. A plus bi and the c plus di all over the same c minus di and the c plus di. Then use this and multiply everything here. Use this and multiply everything here. Do the same thing at the denominator. If you cannot remember this difference of two squares, please do it like this. If you cannot remember that it will form difference of two squares. So doing it like this, I'm going to have a times c, ac. Okay, let me leave it like this and then use number to explain. Okay, but no problem. A times c, ac. A times this will give you what? A di. B times this will give you what? BCI. B times this will give you what? B times D will give you BD. Then I times I will give you what? Minus 1. You see the way I wrote mine. So do the same thing for denominator. C times C, C squared. C times D, you have what? Plus CDI. Minus DI times C, minus CDI. Minus times plus, minus D times D, D squared. I times I, bracket of minus 1. So what do we have now? This one will not make this one minus BD. So go to the side without I. So I'm having AC minus BD together plus these two has I in common. So I'm having AD plus BC with their I all over. So what I'm having here is what? C squared. This and this is gone. Original minus is here times the minus here. I'm having plus what? DI, which is the same thing you are going to get for this denominator. C squared will give you C squared. Original minus is here. D squared is D squared, while I squared is minus 1. So minus minus will still make this place plus. You see that they are the same thing. But if you cannot remember this thing, please do it like this. Please, so that you don't make mistake, please. Okay. So let us solve it with a number for you to understand. Then we are done for this. Then in our next video, we'll now go higher for complex number. Okay? So an example said 2 minus 3i divided by 5 minus 2i. Okay, I have this. We want to rationalize. If you want to rationalize this, they say simplify or rationalize, anyone. Simplify this. Okay, solution. I'm going to have 2 minus 3i all over 5 minus 2i times 5 plus 2i over 5 plus 2i. Okay, so this is equal to, I know what the denominator must give me. It must give me the first person I'm seeing here, all squared, original minus, and the second person I'm seeing here, all squared. That is what it must give me. So let me clear the numerator. This one will multiply everything, and this one will multiply everything. So 2 times 5, 10. 2 times 2i, 4i. I'm done with this. Minus 3 times this, minus 15i. Minus 3 times it. First of all, minus 3 times 2 will give you minus 6. I times I will give you minus 1. Please do it like that so you don't make mistake. So my answer becomes my answer becomes minus is now plus. So 10 plus 6, I'm having what? 16 for the real part. Then 4 minus 15 will give you minus 11i all over. This square will give you 25 minus watch you, 2 squared will give you 4. I squared will give you what? Minus 1. So I'm having what? 16 minus 11i all over. Minus is plus. So 25 plus this will give you what? 29. So this is my answer. But we normally write it as this. Separate it 16 over 29 minus 11 over 29i, so that the real part will stay on its own and the imaginary part will stay on its own. So that is how we do that. Okay? So that is that. I will solve one more question here and then we'll be done for this video. So the last question I'm going to solve here says okay, last question says rationalize 1 minus I all over 1 plus I. Let us do this simple one. Solution. So I'm going to have 1 minus I over 1 plus I times 1 minus I, the conjugate of this one, divided by the same 1 minus I. Okay, we are going to use the conjugate to multiply up and down. Okay, so the answer is, don't forget, this first person will multiply everything, and the second person, if I put them in bracket, so you will be getting it very well. 1 minus I and 1 minus I again. This one is 1 plus I and another 1 minus I. Okay, so this is equal to, let me clear, I don't want to do that difference of 2 squared. Let me just multiply it straight. So I'm going to have 1 times 1, 1. 1 times I minus I times 1 minus I. Watch again. Minus plus I times I minus 1. Are you seeing it now? All over. Let's do the same thing here. 1 times 1, 1. 1 times minus I plus I times 1 plus I plus minus I times I minus 1. You see the way I did it? Please. So I'm having plus minus here is minus. So 1 minus 1 is gone. So I'm left with minus I, which will give you minus 2i all over. Minus I is gone. Minus is plus. So 1 plus 1, 2. So when this divides, I'm left with what? Minus I. So that is my answer. Thank you very much for watching. In our next video, we go further on complex number. Please subscribe.